factoring, difference of squares. So how do we identify when to factor using the difference of squares? It's got to be two terms. And on top of that, the word difference is in what it is, right? So maybe this could be two separate bullet points, but still two terms, and they have to be a difference. Now, this does not mean that there's a minus sign between the two, all right? We're taught to subtract this difference. That's because a subtraction is two different signs. If one is positive and one is negative, it doesn't matter which one comes first. You could have -2 plus x. That's a difference. Okay, even though plus is between them, because one is positive, one is negative. Okay, so the two terms are different signs. All coefficients and constants are perfect squares, and all powers are even. If those things are the case, if those are the criteria that we have, then we have difference of squares. All right, so perfect squares. All right, here's a list. I want you to be really familiar with these. If you're riding down the road and you see a mile marker 289, I want you just to blurt out 17 squared. And then apologize for being a math nerd. But look, I want you to know these things. If you see the number 196, I want you to think 14 squared, okay? That needs to be something that you just immediately think whenever you do that, okay? If you see 441, think, 21 squared. It may not, look, if you see the number 441, it may not have anything to do with 21 squared, but you need to at least be familiar with it to know that, all right? Because it may. So let's consider x squared minus 36, and how do we factor this expression? Well, the first thing we do is say, how many terms is it? It's two terms. Check. Is it a difference? Are the signs different? Well, look, this is a positive and this is a negative. So the signs are different. Yep. So check. Are they perfect squares? And what I mean, the coefficients, the number out here and the 36, that's a 1. 1 squared is 1. 6 squared is 36. Check. Right? That's yes. Then do we have even powers? Well, what's my only power? 2. Is 2 even? Sure is. Check. So guess what? We have now met all the criteria for difference of squares. So look, we're gonna flip the page here and we're gonna go straight into factor completely. So, and I know some of you are like, where's the formulas? Look, here's my feeling on formulas. All right, this is 2 decades in the making, 3 really, counting the years, the decade I tutored before I ever started teaching, okay? So really 3 decades in the making here. All right, formulas are great. We math teachers, we love formulas. Oh my gosh, we love them. You know why we love them? Because we know what's up. We know what's going on. We've seen enough of the problem. We've worked, we've experienced, we've practiced enough of the problems that when we see a formula, we know how to plug them in. But if you're an algebra student and you're trying to figure this out for the first time, you may not understand plugging something into a formula or figuring out what that formula means. So I avoid formulas if I can at all costs. Okay? Now, obviously, if we're talking about the quadratic formula, I can't avoid that. You have to have that formula and know how to plug it in, or you can't use it. Okay? You can't do it. So, but in this case, I don't teach a formula. Special forms of factoring, this is part of that. I don't teach it for the other forms either. I don't have any formulas I give when I teach factoring. I don't give a single formula when I factor. The whole way through all my factoring, I don't give a single formula. All right? Now I talk about what to do, and this is as close to a formula as I will get. Okay? So the other special forms, they're just methods I already use, and you have to recognize something at the end. This is the one that's closest to that. All right? So when we factor, the very first rule we learned in factoring was GCF, greatest common factor. So the very first thing I should do is ask myself, is there a GCF? There's no GCF right here, and we've already gone through all the other criteria for this one, so we know this is difference of squares, okay? But just to make sure, we need to also say, hey, is there a GCF? Because if there is, you always remove it first. You take it out, factor it out first. Here, there's no GCF, so then I'm going to come down here, and difference of squares is going to factor into 2 binomials, just like list method or bottoms up, okay? So if you don't know what I'm talking about, go check out my videos for list method and bottoms up. All right, bottoms up is a pretty common name for that. Many people use it. They use lots of other methods too. List method is something that actually one of my students named what I do, and it's going to be similar to some things you've seen before. But I kind of put it together from many master teachers that I've run across over my career, and then a couple of parts of it are my own. But it always works, so it's great. So here. 2 parentheses, what do you square to get x squared? And this is where the power being even matters, because you just take half the power. You just take x to half the power. So this is going to be x to the first power. So x, and the x's come first in here because the x squared was first up here. If the x squared was second up there, the x's would come second in the parenthesis. The x's come in the same order that they do up. So they're first, they come first. What do you square to get 36? 6. So if 36 is last, then your 6's go last in your parentheses here. Okay? So 6 and 6, and then one of them is plus, and the other is minus. And you say, well, does it matter if I put the plus first or the minus first? It doesn't. But don't put 2 pluses or 2 minuses. That's something totally different. So it's either plus 6 minus 6 or minus 6 plus 6. Okay? So x plus 6, x minus 6 is here. I am predisposed to say x plus 6, x minus 6, and put plus first, probably because my favorite algebra teacher that I had in high school did that. All right? She was wonderful. One of the best teachers I've ever had in my life. And so that's probably why I do it. I don't know. She might have flip-flopped them around or put negatives first. I don't know. I have a student. He loves to do that. It doesn't matter. I'm going to flip-flop a couple of times here and put the negatives first, but then I'll probably revert back to my tendency and I'll put plus first on the rest of them just because that's how I typically operate. So let's go to the next one here, the d squared minus 121. So if I look at this, is there a GCF? No, there's not a GCF. So 2 terms? Yep. Is it a difference? Yep. You got a positive and a negative. It's a difference. Even power? Yep. Perfect squares. That's 11 squared, and then the one out front, we know one's a perfect square. So then this is ready for this. What do I square to get the d squared? What do I square to get that d, right? So put a d first, and d squared is first, so the d's come first. What do I square to get 121? 11. So then I put the 11s last or second in the parentheses, and then one of them is minus and the other's plus. This time I put the minus first. It doesn't matter. It doesn't matter. You can put the plus first or the minus first. It doesn't matter. So let's look at the next one here. All right? Let's look at the next one here. 9x squared minus 25. Is there a GCF? There's no GCF. No GCF. 9 and 25 don't have anything in common. Both terms don't have an x. There's no GCF. So then, does it meet the criteria for difference of squares? Well, it's 2 terms, yes. It's a difference, yes, right? We got a positive and a negative. Is 9 and 25, are they perfect squares? Yep, they are. Is that an even power? Yep. So guess what? It meets the criteria. So we come down here and we say, okay, 9x squared is first. What do I multiply by itself to get 9x squared? And look, this has to be the same thing. You can't put like 5x and 4x. Or 5x squared and 3. You have to have exactly the same thing. Like if I write down 6, I've got to put 6 with it. It's squared, right? That means multiply it by itself. So this is 3x, right? 3x times 3x gives me 9x squared. What about 25? What do I multiply by itself to get 25? Or what do I square to get 25? 5, right? 5 times 5 is 25. And then one of them is minus and the other is plus. It doesn't matter which order you put them in. I did a couple of them in a row with negative. All right, that was hard for me. All right, just because I typically do plus first, but either one's fine. It's not right or wrong one way or the other. So now let's look at the next one. 49 minus p squared. Is there a GCF? No, there's no GCF. No GCF here. So then, and look, I'm talking you through this. This whole thing I'm talking you through. Is there a GCF? Is it 2 terms? Is it a difference? Is it even powers? Is it perfect squares? I'm asking you that. It takes us 30, 40 seconds, a minute to go through that. It should take you about a half a second to recognize that once you get comfortable with this. Your brain is better than any computer that's out there, okay? It's so fast, it's ridiculous. You can go through there, bam, just recognize it, and boom, I got it figured out already, okay? I got it figured out already. So here, if I look at this, you should already have it figured out, but it's 2 terms, no GCF. It is a difference. The positive term is still first, but it looks funny to us because that p squared is second. We think, oh, we got to write the p squared first. This is actually the only time that I don't put it in descending order to factor because this and then there's something called SOPs. That same algebra teacher I raved about a while ago taught me something called SOPs, and that's for the sum or difference of cubes. That's a separate video, right? But that's the only time this and then is the only time I won't put that in descending order just because it just makes all the other factoring and all the other things you do in algebra typically easier when you put it in descending order. Not necessarily wrong or right unless you're told to, but typically that's what we do. So here, I'm just going to leave, on difference of squares, I'm going to leave it in this order, okay? So it is a perfect square. It is even power. It's 2 terms. They're different. There's no GCF. So then 2 parentheses here, okay? What comes first here? 49. So what do you square to get 49? 7. So if 49 is first, your 7s must come first. Okay? This is what my students over the years have struggled with the most in this. They want to put the 7s last because they just think, oh, the variable has to come first. No. If you put p plus 7, p minus 7, that's something totally different than what we're about to write down. The 7s must come first because the 49 is first. And then what about the p squared? Then it's p and p, and then I need to say something about my signs being different. The signs are different on the term that's negative. So if you have it written negative p squared plus 49, then you got to still put your plus and minus on the p because the p squared is negative, okay? So typically we see it with the positive term and the negative term. I don't have any of them written in a different way here, all right, because this is more of an introductory video for this. So p's have to come last because p squared is last, so the p's come last here, okay? Second in the parentheses. One of them is plus and the other is minus. Again, if you put p plus 7, p minus 7, that gives you p squared minus 49, which is different. That's not the same thing, so that's not correct. The 49 is first. The 7s need to come first, okay? The 7s need to come first. So let's keep looking at these. 1 minus 81x squared. Again, how many terms is it? 2. Is there a GCF? That's the first thing I should look for when I factor. Nope, no GCF. Is it a difference? Yep. Positive 1, negative 81x squared. It's different term, different signs. Sorry. Of course, they're different terms, different signs. All right. So then, are they perfect squares? Yep, those two things are perfect squares. Check. And then are the powers even? Yep. Check. So then this is going to be 2 parentheses again. What do you square to get 1? Sometimes we don't think about that as being a perfect square, but 1 squared is 1. Okay, I just answered that but didn't say a thing, but it is. 1 squared is 1, right? So then put your 1 there. That comes first. One's first. One's come first. What do you square to get 81x squared? 9x, right? So that comes second in each parenthesis, and then one is positive and the other is negative. All right? So let's look at the 64m squared minus 9y squared. All right, so look at it. Is there a GCF? I mean, it's got a lot of stuff. We think, oh, it's got to have a GCF. It doesn't. There's no GCF there. How many terms? It's 2. Each got multiple factors in each term, but it's still just 2 terms, right? 64m squared is a term and negative 9y squared is a term. Are they perfect squares? Yep. Oh, and they're different signs. I didn't say. So 2 terms, different signs, no GCF, perfect squares, even powers? Yep. Right. Again, I'm going through all that. It takes several seconds for me to say it. I'm going through it quickly. Your mind should process that literally in a half a second. Okay. If it takes 0.6 of a second, it's too long. Okay. That's a little bit more than a half, right? So here's 64m squared minus 9y squared. So then come down here in my 2 parentheses. What do you square to get 64m squared? 8m, right? 8m. What do you square to get 9y squared? 3y. 3y. So then, and then 1 is plus, 1 is minus. So look, on all of these, okay? Haven't said it yet on this video, I don't think, but on all of these, how could you check this? You could FOIL it, right? If I FOIL this, 8m times 8m, that gives me the 64m squared, right? And then when I do the outer and the inner, that's going to be minus 24my and plus 24my, and those cancel. Right? Those cancel. That's why we're doing this. That's why this works. And then if I do the last, that's minus 9y squared. Look, if you have 2 parentheses that are built exactly the same except for one sign, typically it's the sign in between them, but it doesn't have to be. If the 2 parentheses are built exactly the same except one sign is different, okay? And you FOIL, so it's 2 binomials. They're built the same and one sign is different. When you FOIL them out, the middle terms, the O and the I, are always going to, or well, two terms are always going to cancel out, okay? I guess if you rearrange some stuff, it may not be the O and the I, all right? But 2 things will always, and actually later on in your math life, you're going to use that to your advantage when you do something, okay? Later on in your algebra life, actually. So when you get to something, you'll actually use this whole, plus and minus with everything else the same. And that's going to work to your benefit for something else besides just factoring these. So if I look at this, there's 2 terms here, right? 2 terms. Is there a GCF? Ding, 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 ding. Here there is a GCF, right? What is the GCF here? It's 3. If I factor a 3 out, x squared minus 4, right? 3 and then x squared minus 4. Well, now I've taken a GCF out. Now I look inside here. So let's see. I'm going to go ahead and do this. I'm going to put my 3. Don't forget the 3 is out front. So if you factor this further, don't forget the 3 is out front. And if it doesn't go any further, then this is going to be my final answer. Okay? So, and I haven't been saying this on here. We do take the GCF out. But how do I know when I'm done factoring? When all my pluses and minuses are in parentheses, I have no power bigger than 1 in a parenthesis, and then I don't have any GCFs left, right? So on all the problems we've done so far, all my pluses and minuses are in parentheses. I don't have any powers bigger than 1, right? And I don't have any GCFs in any of my... If you don't have a GCF to start with, you shouldn't have one in any of your factors, the parentheses, because they weren't a GCF in the original problem. So here I have x squared in my parenthesis. That's what tells me I need to try to go further. It doesn't mean it will work, but that's what tells me to try to factor this further, even though all my pluses and minuses, in this case only a minus, are in parentheses. And let me clarify, if this 3 were negative, that's okay to be outside of parenthesis, a leading negative, okay? But it's not negative here, but you could have that, and it's still okay to be factored. But here, that squared is what tells me to try to go further. So I have 2 terms. I have no GCF in there anymore. They're different, right? Plus and minus. Perfect square, 4. Even power, 2. So what do you square to get x squared? X. What do you square to get 4? 2. And then one of them is plus and one is minus. And don't forget that 3 is out front. So that became difference of squares there, but not only was it difference of squares, but it was difference of squares with a GCF in front of it, or before it. So you can stack any kind of, that's the way math works, right? Anything you learn in math is fair game from that point forward, okay? So anything you learn in math, you need to treat like riding a bike. If you learn how to ride a bike, you just never forget. You just get on a bike and ride, okay? So anything you learn in math should be that way. Anytime you approach it later in math, you should, I know how to do that because I saw it 10 years ago in something. Okay? So, and I know that's not how it always works. Okay? But any factoring form is fair game. Once you learn one factoring form, GCF, it's fair game to have a GCF and then list method, or GCF and then bottoms up, or GCF and difference of squares, or GCF and whatever else. Okay? Or mixing up other things. All right? So then W squared plus 25, is there a GCF? No, there's not a GCF. So is it different? Are the signs different? No, they're not. This is positive and positive. They're not different. This is what we call the sum of squares. Okay? This is the sum. That's not the difference of squares. This, we say, is non-factorable. Okay? Non-factorable. So just because we learn to factor something doesn't mean that everything has to factor, okay? So maybe all my videos don't have a non-factorable in them, but it doesn't have to factor. So here, if you get 2 terms, they're perfect squares, even powers, but they're plus, or they're both the same sign. If they're not different signs, then this is going to be non-factorable in the real numbers, okay? We can't factor this in the real numbers, which is what your algebra classes typically cover, okay, or real numbers. We talk about real numbers. And what I mean is, we do introduce that little I. I'm talking about the complex. If you don't know what I'm talking about, at some point you'll see it, right? Probably in Algebra 2, you'll see it at some point, that little I that's the square root of -1, which is weird because we're not used to seeing that, okay? So, but with real numbers, this is not factorable, the sum of squares, all right? So let's factor some more of these, or look at some more of these. They may or may not factor. 18 minus 2v squared. It's 2 terms. Is there a GCF? Yep. What is my GCF? 2. If I take a 2 out, I'm left with 9 minus v squared. So now I have all my pluses and minuses in parentheses, except this time I have a power of 2. That tells me this might go further, right? So even if I glance at it, I can tell it is difference of squares, right? But again, why is it difference of squares? Perfect square, even power, and the signs are different, right? It's 2 terms. And there's no GCF in there anymore. The 2 is out front. So now how do I factor this into difference of squares? Well, what do you square to get 9? 3. So the 3 comes first, right? The v's don't come first. V, to get v squared, you put v, and that comes last or second in the parentheses, right? And then one of them is what? One of them is plus and the other is minus. One of them is plus and the other is minus. So what about 3x to the third minus 48? 3x to the third minus 48. So here, two terms. Is there a GCF? Yep. What is it? It's 3x. If I take a 3x out, I'm left with x squared minus, how many times will 3 go into 48? 16. 3 times 16 is 48. And then I took the x out, so there's no x remaining right there. So 3x times x squared minus 16. All right? And then, again, I look at these two terms. Do they meet the criteria for difference of squares? Well, they're different signs. They're two terms. Even power, perfect square. Yep, that works. So 3x, and then I put my two parentheses. And I'm going to come in here and say, okay, what do I square to get x squared? X. What do I square to get 16? 4. And the 4's have to come last here. The x's have to come first. This gives me the order. And then one of them is plus and the other is minus. And don't forget your 3x is out front. Don't forget your 3x is out front. So w to the 6th minus 4. Right? W to the 6th minus 4. Two terms, right? Yep. Different signs? Yep. Perfect squares. That's a perfect square. The one out here is a perfect square. That works. Even powers. Is 6 an even number? Sure is. That meets the criteria for difference of squares. Okay? So now let's see. This is going to be, well, two parentheses, right? What do you square to get this? And I told you earlier, I mentioned it. You take half the power. That's why the power has to be even. Right? If you multiply two things, what do you do with your exponents? You add them. So if you want half the power, you just take half of, if you want to, you take half the power to square it. That's what I'm trying to say. W cubed, I just said that wrong. I know I did. W cubed times W cubed, if you square that, is W to the 6th. Okay? So when you square W to the cubed, you double the power. All right? So W cubed and W cubed are W to the 3rd. And then what do you square to get 4? 2. 2 and 2. And then one of them is plus and the other is minus. And the powers here are bigger than 1, but we haven't talked about how to do a W cubed with a number. And in fact, neither one of these go any further. Okay? Neither one of those will go any further there. All right, but this third power tells me, hey, try to factor those further. But when I investigate, there's no way to factor this one, nor is there any way to factor that. Okay? So they will not go any further. So remember, a power bigger than 1 doesn't mean it must factor further. It just means it might factor further. All right? So then 9c to the 10th minus 16d to the 8th. All right, so here, two terms. Is there a GCF? Nope. So do we have difference of squares? Well, that's two terms. The signs are different. Those are perfect squares, and the powers are even. So it meets all the criteria. So now what do I square to get 9c to the 10th? Well, to get 9, you have 3, and to get c to the 10th, you do what? Half the power, c to the 5th. So 3c to the 5th times 3c to the 5th, right? And then how do you get 16d to the 8th? Well, 4s, and then d to what power? The 4th, right? Half of 8 is 4, so 4d to the 4th. And then one of them is plus, and the other is minus. Again, you have powers bigger than 1, but if you investigate that, there's no way to factor either one of those, okay? So that is our final answer there, right? So I didn't have these pre-planned on here, but I want to add a couple of things on this next page just to show you with this non-factorable here. So let me give you something like 2x squared minus 3, okay? So this can fall apart for various reasons, or we have x cubed minus 2, all right? So we have two terms here on both of these, right? We have two terms on both of these here. So is there a GCF on this one? No. Is it different, though? It's two terms, different signs. Yes, both those things are okay. The power's even. Are they perfect squares? Well, look, 2 and 3. It only has to be one of those. In fact, both of those are not perfect squares here. So this is non-factorable, and you can write NF for me, okay? Non-factorable. You can write it won't factor, it will not factor. However your teacher wants you to say it won't work, okay? It's not going to factor. But look, don't put no solution. You're not solving. Don't put not real. You're not talking about real numbers here. You're talking about will it factor? It won't factor. So something negative in factor is what I tell my students. Okay, they can even tell me it ain't going to factor. All right, so here I have two terms. All right, this one fails on two counts, by the way. They're different signs, but you don't have an even power, and that's not a perfect square. Right? Both it fails on both accounts. It only has to fail on one thing, right? Like the one earlier had the plus sign. So again, this one is non-factorable. Right? So it can fail on any of those accounts of the criteria, whether the not a perfect square, or whether it's not an even power, or whether it's something else. Okay, so but these will not factor here. So hope this helps you out with difference of squares and factoring.